This is our Chapter 4 study cast for Thursday's Chapter 4 math test. Rachel drew an array to show the number of stamps on a page in her scrapbook. There's a picture of the array. Which multiplication sentence shows the total number of stamps on a page of Rachel's scrapbook? So you have an array here for this problem to help you. So really all you have to do is count the rows and the number in each row to give you the multiplication fact. Michael, go ahead. Great. We have 1, 2, 3, 4 rows with 1, 2, 3 items in each. So that would be 4 times 3 equals 12. Who can use the commutative property of multiplication and give me the other multiplication fact for this array? Christina. Great. Next problem. Julio has a collection of coins. He puts the coins in 2 equal groups. There are coins in each group. Looks like that I cut a number off of that one. So let's say there are 7 coins in each group. How many coins does Julio have in all? So they gave you a number line here to help you if you wanted to count 2 groups of 7 coins. You could use the number line. You could skip count by 7 2 times. So you'd count from 0 up to 7. And then 1, 2, 3, 4, 5, 6, 7. You would make 2 jumps of 7 each. And that would take you to what product, John? 14. Also, you could have skip counted twice by 7. 7, 14. Who can give me the multiplication sentence that we can use to solve this problem? Jojo. Great. Rita arranged counters in 5 rows with 7 counters in each row. Which array shows how many counters she arranged in all? So I'm looking at these choices, and right now I want to use process of elimination because there's one that I know is not correct. There's no way that it's correct. Which one can I eliminate right off the bat? Gianna. You can definitely eliminate choice C because there's no way there's 5 rows in that array. Okay, it could represent the product maybe, but there's no way that that's 5 rows. Who can find the array that represents 5 rows of 7 counters? Kyle. Choice D is correct. Here's something else that I noticed. I'm looking at choice A, and I see that that looks like a square, not a rectangle. If an array looks like a square, what does that tell me about the 2 factors used to make the array? Let me count them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Interesting. So every time there's an array that looks like a perfect square, it tells you that the 2 factors to make the product are the same. And that's because squares have sides that are the same. They are equal in length. So when it looks like a square, you know that the 2 factors are the same. Now earlier I said that this choice C, that might represent the product. Could that array represent the product of 35 without even counting those? Kyle's shaking his head no. Explain why. Could you break 35 objects into 2 equal rows? Don't count. I don't even want you to count. You should be able to explain to me without counting. No. It's not that. No, I don't want you, we don't need to do any counting. There's a way that you should know that 35 could not be divided equally, 35 objects could not be divided equally into two rows. What is it, Jojo? What's the explanation? Not because 3 is an odd number. You're on to something. You're close. Okay, so 35 in the ones place, you have an odd number, right? 3 is an odd number, but I can think of an even number that has 3 in the tens place. Isn't this an even number, 32? Yes. So it doesn't have to do with 3 in the tens place. It has to do with 5 being in the ones place. If the digit in the ones place is odd, then you cannot split it into two equal rows. Mrs. Morelli said that this year. Okay, let's not get confused about what we're talking about, okay? I think you're thinking back to the beginning when we talked about odd or even and adding them together. And we said even plus even is even. Odd plus odd is even. Even plus odd is odd. Right. I think that's what you're thinking of. Okay. Madison makes 4 types of hair ribbons. She makes 3 of each type of ribbon. How many hair ribbons does Madison make? So she has 4 different types that she's making. She's making 3 of the first type, 3 of the second type, 3 of the third type, 3 of the fourth type. How many ribbons in all is she making? Michael, 12. Tell me the multiplication sentence you used to find that answer. Great. Perfect. Kyle bought 4 erasers at the school store. Each eraser cost 10 cents. How much did the erasers cost in all? Now this problem gives us a bar model. Okay, we've used the bar model before in addition and subtraction. This time we're using it in multiplication. So we are shown 4 different sections for the 4 erasers, and each one was cost 10 cents. So how much did the erasers cost total? Christian? 40 what? Great. So this one we can just skip count 10, 20, 30, 40, or you could do 4 times 10 cents. Cho is making a pentagon with straws. She uses 5 straws for each pentagon. If she makes 3 pentagons, how many straws does Cho use? So she's using 5 straws each. She's making 3 pentagons. How many will she use for all 3? Mia B? 15. Tell us how you found it. Okay, and that's the same, skip counting by 5 3 times is the same as doing 3 times 5, or 5 times 3. Elvira bought 4 packages of stickers. There are 6 stickers in each package. How many stickers did Elvira buy? How do we solve this one? 4 packages, 6 stickers in each package. Boys and girls, notice what I'm doing each time I read one of the word problems. I'm thinking aloud for you. And after I read the problem, I'm explaining to myself and to you exactly what we're looking for. So after reading that word problem, I said to myself again, and I said out loud, 4 packages, 6 stickers in each. We want to know how many altogether. That's a good thing that you should do after you read a word problem. Say to yourself, after you've read all that information, okay, what numbers am I given and what exactly am I looking for? And there was something that I did earlier with Madison and the types of the hair bows, right? Madison was making 4 types of hair bows. She was doing 3 of each bow. So instead of just skipping to it and say, okay, I see a 4, I see a 3, this is a multiplication test, let's multiply those numbers. Instead of doing that, I said to myself, all right, well, she's making 4 types and 3 of each. So she's making 3 of the first type, 3 of the second type. I kind of told myself a story and I imagined what she was doing. It's an important thing to do when you're reading word problems Because when we're taking a a multiplication test, and all of the questions are in multiplication, it's very simple to say, I see two numbers, let's multiply them, and that's the answer. But when you take a test or complete an assignment when there's all different kinds of operations you have to do, it's not going to be that easy. So you need to kind of make a mental movie of the word problem. So back to Elvira. 4 packages, 6 stickers in each. How many altogether, JoJo? Good. And how'd you find it? Okay, so you made an array, and how many rows did your array have going across? 4 rows with 6 in each, right? Okay, so that's an array that shows 4 rows with 6 x's in each, okay? This represents package, 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 4 packages with 6 stickers in each. Good. So you made a visual representation, and then did you count the x's in your array, JoJo, or did you write a multiplication sentence? Oh, good. So you solved it 2 ways. So you did 4 times 6 equals 24, and then you checked your work with an array. That's great. John? Wonderful. Tell me how you did that. Okay. Okay. So John chose to use the distributive property. Okay, so he did 6 times, instead of doing 6 times 4, he broke 4 up into 2 plus 2, right? He used that distributive property. And then he multiplied each 2 by 6, and he added them together. Good job, John. Good thinking. Yes, Isabella? Okay, I don't understand what your thought is. Can you try? Okay, so if Isabella was using the distributive property, she would have done 4 times 3 plus 4 times 3, because that's easier for you. But that's the beauty of the distributive property. You do what works for you. What did you do, Richie? No, 12 times 12 would have gotten you somewhere else. That would have gotten you to 144, not the same. Next question. Crosby writes a number sentence that is an example of the distributive property. Here we go. Which shows Crosby's number sentence? So you have to tell me which of those shows the distributive property. So remember, you are breaking apart one of the factors into 2 smaller pieces. And when you add those 2 smaller pieces, they give you the other factor. So we're looking for something here that uses both addition and multiplication. Okay, so let's use process of elimination. We have multiple choice. Which choices use addition and multiplication? Joanna? A. Any other one? Richie says B. Okay, let's cross out C and D because they do not use addition. So we know that they don't demonstrate the distributive property. Okay, maybe they're showing something else. So distributive property, I'll say again, is when we take one of the factors and we break it into 2 smaller parts. Which choice, A or B, shows the distributive property? Elias, you can do this one. B is correct, because what they did with B is instead of doing 6 times 7, they broke 7 up into 4 plus 3. Good job, Elias. Next one. Henry and 5 friends are going to the movies. Tickets cost $8 each. Henry used this model to help him find the total cost of tickets, which shows one way to break apart the array to find the product. So what multiplication fact are we working with in this word problem? Tell me the multiplication sentence that we're working with, Joe. I'm sorry. Yep, 6. Not 6 groups of 6. So we have Henry and 5 friends. This is 6 people. 6 times 8 is what we're looking at, okay? But they're asking us to use the distributive property here because they're asking us to break apart the array to find the product. So instead of doing 6 times 8, what's another way to break apart the array? Take a look at those choices and see which makes sense. I see one that I can eliminate right away. Which one can you eliminate?
D.
Definitely D. This, I don't even know what this is. This is not, this is telling us, well, I'll tell you, no, this is not, because this is addition here. So what this is this is 16, 6 plus 16. So this is not anything that we're learning about right now. Find the choice that shows another way to do 6 times 8. Christian. A is correct. They're doing 6 times, instead of 8, they're doing 5 plus 3. Who can find the product? Your choice. You can solve it this way, or you can solve it this way. You can do 6 times 5 plus 6 times 3. Solve it. Brianna, 48 is correct. There were 2 walls in Yolanda's classroom that each have 2 rows of pictures. Each row, can't see the word each, but each row has 3 pictures. How many pictures are on the walls in Yolanda's classroom? Here's a really important time to play a mental movie in your mind. Let's draw it out. 2 walls in the classroom. Each wall, so I've got this part, each wall has 2 rows of pictures. And each row has 3 pictures in it. So 2 rows of 3 pictures on each wall. Now I know that some of you can look at that and solve it right away. So let's go with the product. What's the answer for this one, Michael? Not 6. How many are on this wall? How many pictures are on this wall? How many are on this wall? How many altogether? There's 6 over here, and there's 6 over here. 12 altogether. Boys and girls, who can look at this problem and tell me what number sentence could we write and what property of multiplication would we be using? Think about what you're really doing here.
I can tell you the number sentence. I can't do the thing.
Tell me the number sentence then, Richie.
6 times 2.
But where are you getting 6 from? Look back at your word problem. Do you have the number 6 in your word problem? How did you get 6? How did you get 6? Now 3 plus 3. Tell me a multiplication sentence that would get you to 6.
3 times 2.
3 times 2. Okay, so you did 3 times 2 to get 6. And then what did I multiply that by? Once I got 6, what did I multiply that by, Kyle?
You multiplied it by 2 and then got 6.
Awesome. What property of multiplication did I just show you? Yes, Isabella, associative property. Didn't I just group 2 factors together? And let me ask you this. If I use the same 3 factors and I grouped them this way, I would get 3 times 4, and wouldn't that give me the same product? There we go. Associative property. Excellent job. Last one. Use the factors 7 and 6 to show an example of the distributive property of multiplication. Everybody do it now. Reread it. It's right there. So you're choosing one factor to leave as it is. So you're either going to multiply 6 or 7 by one of those factors broken up into 2. So your choice. Think of which one you're better with multiplying, and then make your decision. What did I answer? So I'm going to share with you what I would do. We love our little 7 song, the happy birthday, right? 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. So, if it were me solving this problem, I would choose to multiply with 7. And I would break apart 6. I would break 6 apart into my other favorite song to sing that I share with you from Schoolhouse Rock. That's right. I would break it into 3 plus 3. Now let's figure it out. What is 7 times 3? You can use either song. You can count 7, 14, 21, or you can do 3, 6, 9, 12, 15, 18, 21. So we know that we have 21 here plus 21 here, and what's the product? Christian, you got it. And that'll do it for our study cast for Chapter 4. See you next time.